Okay, this is the second video on this particular problem. Remember, what we're looking at is an observational study of salaries and whether there's gender inequity in how much women are paid compared to men. So let's go on to the second page, and we're going to conduct a single test for whether any of the available predictors and variables in Model 1 have any worth in explaining the response variable of the logarithm of the bank salaries. Conduct your test at level 1%, show your work, and you interpret your results in everyday language. Well, okay, does have any worth? So this means then an overall F test. All right, so what we would say in our null hypothesis would be that all betas are 0. Except for the intercept. If we went ahead and looked at our model on our bank salaries, you can see here in Model 1, we've got constant senior male, age, education, experience, sex times age, sex times education, sex times experience. So we could go ahead and write out what that model is, just to kind of remind ourselves. So remember, what's on the Minitab output is the model. Is the sample, and the model itself would look something like on this page. So when you're asked to ask for the model, use the betas, and when you're asked to find actually the sample result, then that's where you use the B's and BI's. Okay, so just to represent this, we'd have beta 2 senior plus beta 3 male plus beta 4 age plus beta 5 education plus beta 6 equals experience plus beta 7, which is sex times age, which would be x2 times x3. We're not out of room here. Beta 8 would be x2 times x4 plus beta 9 x2 times x5. Age, education, experience plus epsilon. So probably a better way to say this would be beta 1. Remember, you don't include, for the null hypothesis, you don't include beta naught. Beta 2 ... equal to beta 9, or all equal to 0. Remember, the alternative is not none of them are 0 or non-zero. All are non-zero. Sorry, that's not the negation of that. It's saying at least one beta I is non-zero. Now, there's other ways to say this in your overall F test, but we'll just use that for shorthand. The reason why I like the betas for when I'm calculating is that it's easier for me to do the calculation. Now, if I was doing a report to my manager, then that might be something else. All right, so let's go ahead and take a look at Model 1 in terms of our Minitab output. Well, okay, so I've got that. Overall F test, I need to look at the F statistic. So there I go, 11.88. And so my overall F is equal to 11.88. I probably should have given myself more room. My p-value, and you should need to report this, should be equal to the F CDF of 11.88. Put a very large number, so I don't know, 100,000, I'll just put a very big number because that's supposed to stand for infinity. 8 degrees of freedom in the numerator, 84 degrees freedom in the denominator. To see where that would be, remember this is degrees of freedom here for the regression, and the residual gives you the 84 degrees in the denominator. And so that's 11.88. And so here's my overall F, my p-value, and that's essentially 0. Let's kind of do that on Minitab. So I would go to graph, probability distribution plot, view probability. I'd want the F statistic. And you need to communicate somehow that you know what the degrees of freedom are the numerator and the denominator on an exam. And so we're given the F value of 11.88, and we want the right tail. We get the p-value as being 0.0000, yeah, just a very big number, which, I mean, very, very small number, I should say. So 3.54 times 10 to the negative 11. I would say that there's very strong evidence that we should reject the null hypothesis. And so, see, I would usually have more room. You'll have more room because you'll have just a sheet of paper. I'll put it over here, reject null hypothesis. We're not done. We should always put our conclusion into context, and so at least one predictor variable is needed. Or you could say at least one predictor variable adds utility to the model. Okay? All right, let's go on to the next question. Let's conduct a single test whether there is interaction between the predictor variables male and a set of predictor variables age, education, experience. Conduct your level at 5%, show your work, and interpret your results. Now, you wouldn't necessarily have interaction there. It could say, does male have an effect, or does age, education, experience have an effect on male? So there's just different ways that you could phrase that, and so you just have to be careful of what you end up looking at. So, all right, so let's take a look at the model then. If we go to this very top model, what we would say is our null hypothesis is that beta 7 is equal to beta 8 is equal to beta 9 is 0. So they don't add any utility to the model. Another way you could say that is that model 2 works. If I could spell model 2, you could say model 2 is fine, and the alternative is that at least one beta I is non-zero. That is, they add utility to the model, and so what you'd have to say then is model 1 is needed. That's kind of a shortcut way. You could say that at least one of these beta i's add utility to the model, or at least one of the interaction terms is needed. And so, I mean, you could use a lot of the language that's found on page 162. You know, either they're all 0, at least one of the coefficients is non-zero. We can reduce eliminating the variables of these interaction terms. At least one of the prediction is available. And you could say also there is no interaction. Sorry, down here. There is no interaction between gender and education experience and age, or there is interaction between gender and interaction, at least one of those, interaction between gender, education, experience, and age. All right, so let's take a look. Now we're going to do a partial F test because we have more than one. So you might want to claim a partial F test because we're throwing out some and keeping others. So the F, we're going to have to take a look at model 2 and model 3. Okay, so here's model 2 and model 3, and you'll be given the partial F test for the exam. So the partial F test, remember, is the sum of square error reduced minus the sum of square error full over degrees of freedom of reduced and full. And so let's see if I can remember that. You don't have to remember that. So sum of squared error reduced minus sum of square error full divided by the degrees of freedom of reduced minus degrees of freedom full all over the mean squared error of full. All right, so let's see if we can find. Not doing a very good job of keeping my video on the right spot. So let's see if we can calculate these numbers from what we have. So the sum of squared errors from model 2, again, this is the residual error. That's 0.73454. And 0.73454 minus something. The degrees of freedom for the reduced turns out to be 87. And then let's go to the full model. Full model is what we have here. Its residual error is 0.72064, and its degrees of freedom is 84. And then we also need the mean square error, which is this 0.0058. All right, so if we reduce all of that, I believe we get 0.54. And so now let's take a look at our F statistic, our little slide. 0.54 is here. We need to find all this area here. So the p-value is equal to FCDF going from 0.454 to a really big large number, and I'll put what you have in there. 3 degrees of freedom in the numerator, because you have 87 minus 4 is 3, and the degrees of freedom in the denominator is 84. And if you do that, you get 0.656, which is, boy, that's quite bigger. So the p-value is bigger than 0.05 by a ton. So we do not reject the null hypothesis. Now we need to put in stat language, or that's the stat language. We need to put it in what we can use. There is, now let's try this again. The data do not give evidence, because remember, this is a sample and the data could have been different, that there is an interaction between gender and age, education, experience. So what we're doing is we're saying, okay, model 2 is what we're going to go with. There are no interaction terms. And that's why it's good to write your null hypothesis, because after you do all these calculations, like, hey, what was I trying to do? And so we'll move on then to the next question, as far as what are we going to find out as far as the main